Hi students, myself Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering. Welcome you all in my fourth lecture of periodic table. You know, in the previous classes of the periodic table, we discussed about the properties of the different elements. We already discussed about the screening effect, effective nuclear charge, and also ionization potential. Today we will discuss about the electron affinity. We will discuss about the electronegativity and also what are the differences between electronegativity and electron affinity. There are some factors also which control electronegativity and the electron affinity. We will discuss that kinds of factors. Then we will discuss about the polarization of the orbitals. You know, these factors is very important to understand the percentage of the covalent character of a bond. That means it is the Fajans rule. So today we will discuss about the Fajans rule, and at last we will discuss about the penetration of the orbitals. So without further delay, let's start the class.
What is the electron affinity, or there is another name, that is the electron gain enthalpy? How we can define the electron gain enthalpy? We can define the electron gain enthalpy in this way. For an isolated gaseous atom, what is the meaning of isolated gaseous atom? Suppose we are taking any of the atom X, okay, in gaseous state. This is the isolated gaseous atom. Okay, so for isolated gaseous atom, when we add one extra electron, then what happen? One X minus ion will be produced, okay, in gaseous state plus energy. Okay, so now how we can define the electron affinity or electron gain enthalpy? We can define in this way that the amount of energy released when one extra electron is added in the last orbital or last subcell of an isolated gaseous atom in its ground state. What is the meaning of isolated gaseous atom? That means it is the single atom. There is no interference of any other atom or the molecule on this particular atom. Just keep in mind, this is the theoretical condition, because it is the ideal condition, because in the practical scenario this is not possible to make an isolated gaseous atom. Okay, so theoretically how we can define that the amount of energy released, okay, to add an extra electron to the outermost shell of an isolated gaseous atom in its ground state, this amount of energy is called electron affinity or electron gain enthalpy. Now, if it is the E1, for example, we are taking it E1, then what happen in the second step? Okay, if we continue the process, then we can write down X gas X minus, okay, because we are taking this anion in the second step, plus again we want to add one electron. So what happen? Then it will be X2 minus gaseous, isn't it? But in the second step we have to provide the energy in state of energy coming out from the outer energy coming out from the atom. This is the very interesting, it is the E2. Okay, so not like the ionization potential, because in case of I already discussed with you that in case of ionization potential, that in the second step, if we continue the process, in the second step more energy we have to provide, but here it is totally opposite. In the first step energy coming out from the system, but in the second step energy we have to provide to the atom. Now we will try to understand that why energy is coming out or why we have to provide the energy in the second step. So when we add one extra electron, for example, this is the nucleus, okay, very simple thing, the nucleus, and this is the, for example, this is the cell, okay, and we are adding one electron to this particular cell, okay. So you know there is a particular number of proton, okay. For example, there are x number of proton and x number of electron, x number of proton and x number of electron at the first stage. Now when we add one extra electron here, then what happen? Proton number same, but electron number will be x plus 1. So x number of proton is able to attract x plus 1 number of electron. That's why the energy coming out from the system. So why energy coming out from the system? That means if we again want to remove that electron from the subcell or from the outermost cell, then we have to apply the energy. That means electron is stabilized by releasing this amount of energy in the first stage when we are considering E1. Keep in mind, when we are considering E1. Okay, so in the case of E1, energy is coming out from the system. Why? Because the nuclear charge is able to carry or to attract or to be to form a stable anion, okay, in this way. So electron will be stabilized. That's why energy coming out from the system. And if we want to release this electron again, we have to apply this same amount of energy there. But in the second case, what happened? Already there x plus 1 number of electron present. That means one extra electron already present there. So again we are trying to add one extra electron. That means the number of electron become x plus 2. So x plus 2, that means 2 electron greater than proton. So in this state, actually our nuclear charge or the number of protons, x number of protons is unable to carry or to contain or to attract or to be a complete cell. Okay, it is unable to attract the x plus 2 number of electrons. That means that electron again, when we want to add, okay, extra electron, this electron will not be stabilized. That's why energy is not coming out from the system. And for this reason, actually in the second step we have to apply the energy if we want to add one extra electron to the system instead of energy coming out from the system. So just keep in mind, this is very important question from your exam point of view. The common form of the question in this way, that of why the first electron affinity is positive, of why the second one is negative. Normally or generally, positive means electron energy coming out from the system, and negative means we have to apply the energy to the system. Energy is not coming out to the system. Or you can see there in the question in the form also, like to the case of a particular atom like oxygen. Okay, so why the first electron affinity of oxygen is positive, whereas the second electron affinity of the oxygen is negative. Okay, so you have to explain this thing in this particular way. Okay, now come to the point that on what or which factors electron affinity depends on. Okay, that means on which factor control the electron affinity. So first of all we'll consider the, if you consider the factors, then the first factors, okay, if we consider the first factor, then the first factor will be it will be effective nuclear charge. Okay, effective nuclear charge. I already discussed with you that what is the effective nuclear charge or the Z star. Okay, so effective nuclear charge is the first factor. Why? Because I just told you in the last slide that nuclear attraction force is the main fact. Okay, nuclear attraction force, because if the nucleus is unable to attract the last electron or to carry the last electron, if it's the nucleus and if it's the last electron, so what is the attraction force to the last electron? Okay, this actually determine that how much energy will be released from the system. So that's why it is very, very important that with increasing the effective nuclear charge, okay, the electron affinity will be increased. So look here, effective nuclear charge also reflection of the size of the atom, isn't it? If it is increasing, then obviously size will be increasing. So there is a direct relationship between effective nuclear charge and the size. So, or on the other way, we can tell that from the left to right, from the left to right, the size of the atom that decreases. Why decreases? Because that from left to right the effective nuclear charge increases, so that's why the size of the atom decreases. So size of the atom decreases means obviously from left to right EA or electron affinity, it is a short form of EA will be increasing. So according to the period, you have to keep in mind, according to the period the electron affinity increase. Okay, this is very, very important fact which you have to keep in mind. So according to the period, what is the conclusion of effective nuclear charge? According to the value of the effective nuclear charge from left to right side, the electron affinity value will increase. So in the same way, it will be opposite if we consider from top to bottom. So according to the group, obviously electron affinity value decreases, because according to the group, okay, from top to bottom, electron affinity value decrease. Why decrease? Because according to the group, from top to bottom, their size will be, what happened? The size increases. So size increases means, if size increases, this is the reflection of effective nuclear charge. So effective nuclear charge, obviously it will decrease according to the group. So if it decrease, size increasing and EA will decrease. Clear? So what is the result? Result is that according to the period, EA will increase, and according to the group, EA decrease. Now second factor. Come to the second factor. What is the second factor? Second factor is that electron affinity value depends on which subcell actually the electron enter. That means if it enter to the S subcell, okay, if it enter to the NS subcell, then it will have the highest electron affinity, then NP, then ND, then NF. So you have to keep in mind this order, that electron affinity value largely depends on NS, NP, ND and NF. Okay, so maximum energy coming out from the NS subcell. That means if the electron enter to the NS subcell, we can expect that maximum electron will coming out from this subcell. Okay, so nature of the orbital or subcell is very much important factor. Third factor, what is the third factor? According to the third factor, that their half filled or full filled orbital, just like the previous case, like of electroionization potential. Okay, so that half filled or full filled orbital is very stable if you think about the nitrogen. Okay, so in case of nitrogen, okay, or if it is the nitrogen, if you think about the neon, okay, then what happened? It is the full filled orbital. It is the full filled orbital. So either nitrogen or neon, you see that they're half filled or full filled orbital. Now there is no chance or no tendency to add one extra electron to this orbital or to this subcell. Okay, there is no tendency. So if you consider the nitrogen, there is no tendency to add one extra electron. That means it will be destabilized. When there is a chance of destabilization, then obviously there less amount of energy coming out from the system, because in our earth, in our universe, there is no such kind of system which system wants to destabilize itself. isn't it? So that means if it is half filled, it is highly stabilized. If it is full filled, it is also highly stabilized. So there is no chance of adding, or no chance of any tendency to add one extra electron. So if we want to add one extra electron, then obviously the amount of energy will not be very high, because the system will not be stabilized. Energy released because system will be stabilized. That's why energy released, because energy will be decreased. Okay, so if energy will be decreased, then it will be highly stabilized system, isn't it? So that means half filled, if which subcell the electron entered, if it is half filled or full filled, we can't expect very high energy or very high electron affinity value from there. Okay, now come to the next topic, and next topic is another very important topic of the chemistry. This is the electronegativity. Okay, or in short we can write down EN. What is the electronegativity? Okay, so electronegativity we can define in this way. For example, this is the A and B. Okay, A and B. So when two atoms are attached in a covalent bond, then what happen? Their electronegativity means their tendency to attract the bond electron pair towards itself. That means if it is the bond, and if B electronegativity is greater than A, then what happen? B has a tendency to attract the bond electron pair towards itself. So B will attract the bond electron pair. So if B attract the bond electron pair, electron density will be higher on the B, and in this way B will get the delta negative sign and A will get the delta positive sign. So that means if two atoms are attached in a covalent bond, then which atom has the higher electronegativity, it will be the delta negative charge, and delta means it is not a fully anion, it is partially negative charged. Okay, so now come to the point how we can define the electronegativity. So electronegativity can be defined in this way, that it is the tendency to attract the bond electron pair. It is the tendency to attract the bond electron pair towards itself. Just keep in mind, there are some terms which you have to mention in the definition. It is not the inherent property. That means it is a relative property. Relative property means, what is the meaning of relative property? That when it attached with a covalent bond, then only we can check its electronegativity. How? Because if here B is the more electronegative than A. Suppose B again attached with the C, and maybe C is highly electronegative than B, isn't it? So that means that it depends on the other atom, the electronegativity of the other atom. So that's why it is called the relative property. It is not the inherent property. And also the result of the electronegativity is the dipole moment. Okay, there will be two pole, two different pole are created. So this is the dipole. Okay. And another way that it is only possible when it attached with a covalent bond. Now how we can differentiate, because both are the tendency of attraction of the electron pair. So how we can differentiate electron affinity and the electron negativity. Okay, so electron affinity and electron negativity. So electron affinity, it is applicable for isolated gaseous atom. Okay, it is applicable for isolated gaseous atom, whereas electronegativity is applicable when the atoms are attached with a covalent bond. So this is the first difference. Second difference, electron affinity, it is the inherent property. Okay, it is the inherent property. That means it is a property cannot be changed. It cannot be depends with others, isn't it? But electronegativity, it is the relative property. That means it depends on other. Okay, third difference. Electron affinity, electron affinity, what is the result of electron affinity? The result is that generation of the anion. But what is the result of electronegativity? The result of electronegativity is generation of the dipole moment. or dipole, generation of the dipole. Okay, so the result of electronegativity is the generation of dipole, and result of electron affinity is the generation of the anion. Okay, so these are the differences which you have to keep in mind, because this is very important for your exam purpose. Okay, there are so many and the differences also, like starting from the from your isolated system or inherent property, or it is a generation of the anions. Okay, there may be some kinds of factors also involved in this case. So from this point of view, we can differentiate between electron affinity and electronegativity. Okay, come to the next topic. So polarization means it is the deformation of the anions. Normally what happen, anions, the size of the anions become larger with respect to the cations. Okay, so then what happen when one anion attract the when one cation attract the anion, then what happen, the size of the anion gradually changed. Okay, and gradually it overlap with the cations. Okay, and in this way one covalent bond is formed. You know very well that covalent bond means it is the overlap of the orbital, otherwise it is not possible. If there is any overlap of the orbitals, then only it is possible to form the covalent bond. Okay, so now look here, if it is the overlapping of the covalent bond, then when the overlapping will be more, okay, overlapping between the two orbitals, when the overlapping will be more, then obviously there the chance or the percentage of the covalent bond will be more. Actually there is not such kind of anything that 100% covalent, 100% ionic. It is not like that. All the bonds have some character. Where the covalent character is more, we call this is the covalent bond. When ionic character is more, ionic character is higher, we call this is the ionic bond. Okay, so in case of covalent bond, the main important factor is the overlap or overlapping. If the overlapping is higher, then it is considered as the covalent character is higher. Okay, so according to the theory of the polarization, that when the size, it is also the Fajon's rule. Okay, so according to the name of the scientist Fajon. Okay, so you have to keep in mind that polarization and the Fajon's rule, okay, Fajon's rule, they are interrelated. Actually Fajon's proposed one rule by which we can determine the chance or the percentage of the covalent character, okay, in a particular compound. How we can determine? Okay, so if there the size of the cation, okay, if the size of the cation is very small, and the size of the anion, this is very large, then what happen, then the cation attract the anion, and anion gradually overlap with the cation. Okay, so that means if the size of the cation is very small, if the size of the cation is very small, and if the size of the anion is the large, then we can tell that that the percentage of the covalent character will be higher. Percentage of the covalent character will be higher. So this is the point by which we can understand whether there will be higher covalent character or not. Or there may be some kinds of question you can expect from here, that why or there may be some kinds of two cations and two anions, and where you will see that where the size of the cation is smaller and where the size of the anion is larger, there you have to write down that okay, this is the highest covalent character, there is a chance of the highest covalent character in this case. Okay, and it is also the Fajon's rule. Okay, so there may be some kinds of examples are there, that if you think about that anion will be same, and the cation will be sodium plus and magnesium plus. Okay, now you have to tell sodium plus or magnesium 2 plus. Okay, so whatever, or if there is magnesium 2 plus, so in which case the size is the smaller. Or another case, okay, on another case also there, that you have to check the charge also. Okay, charge means if the charge of the cation is higher. Okay, so if the charge of the cation, like if here is the X plus and Y 2 plus. Okay, so if the charge is higher or comparable size, then if charge is higher, then obviously it will deform the anion more. Okay, that means there will be chance of covalent character will be very, very high. You have to check also these things. Okay, so such kind of examples you have to check this kind of covalent character. Another thing that you have to know, that on which factor electronegativity depends. Okay, electronegativity depends on which factor, of what is the trend of the electronegativity according to the period and according to the group. So first of all, you have to know that electronegativity obviously it increases. Okay, so it increases with decreasing the atomic size. Okay, with decreasing the atomic size. This is the main fact which you have to keep in mind. Electronegativity decreases with increasing the atomic size. So according to the period, what happened? Electronegativity decreases, because according to the period atomic size will decrease, and according to the electronegativity, what happened? It will be increase. So according to the period, electronegativity increases. Why? Because atomic size decreases. Now according to the group, what happened? Obviously according to the group it will be opposite. According to the group atomic size increases, so electronegativity, what happened? It decreases. So according to the group, you have to keep in mind decreases. And that's why you know that fluorine has the highest electronegativity. If you compare the electronegativity, then this is the periodic table. This is the periodic table in this way, and here fluorine exists. So fluorine has the highest electronegativity, because from left to right the electronegativity increases, from top to bottom electronegativity decreases. So fluorine will be the higher electronegativity from this according to this order. You have to keep in mind this fact. Second thing, that the oxidation state of the atom, this is very, very important. Okay, if the oxidation state if it is higher, then obviously electronegativity will be higher. If it is higher, then obviously electronegativity will be higher. Okay, I am giving you one example. Look here, that if there is the X plus and X2 plus, so obviously for X2 plus, here is the higher electronegativity. Okay, so in this way you have to check that either there is an oxidation number is very high, so that indicate their electronegativity will be also high. Okay, now we'll discuss about the penetration of the orbital. Okay, orbital penetration. What is the meaning of orbital penetration? Orbital penetration, we can define that it is the tendency to move towards the nucleus. Okay, it is the probability of being found near the nucleus. Okay, and in a given quantum cell, this probability goes on decreasing in the sequence of S, P, D and F. We can show the penetration of the orbital in this way. Look here, that if it is the nucleus, then penetration means how it will be the towards the nucleus, how the attraction will be towards the nucleus. Okay, in this way. So their S orbital, if it is the S orbital, then S orbital has the maximum tendency to move towards the nucleus. If it is the P, then D, then F. So orbital penetration order will be first of all S, then P, then D and after that F. So this is the orbital penetration order. So penetration we can define it is the tendency to move towards the nucleus, and the order will be first, in this case first will be the S and last least will be the F. Okay. So this is the overall syllabus of your periodic table. So you have to keep in mind that the difference between electron affinity or electronegativity is very, very important. Ionization potential we discussed in the previous class, and also there you have to know what is the polarization or how polarization affect on the covalent character of a particular bond. This is very important also, and from there you have to know that what factors are mainly involved, or what factors are mainly responsible to control the electron affinity or ionization potential or electronegativity. Okay, because from these factors there are several kinds of question you can expect. Okay, there may be some kinds of comparison, or there's another important fact that half filled and full filled effect. Okay, half filled orbital and full filled orbital, they are highly stable. That's why there are sometimes, like in case of ionization potential, if you check nitrogen and oxygen, the order become opposite. What is the trend? The trend will not be properly followed by the nitrogen and the oxygen. So these facts you have to keep in mind. Okay, and you have to check all these type of exceptional cases, and okay, so you have to read all that things carefully, and thanks for attending my class. Goodbye, take care, meet with you in the next class with a different topic. Thank you.